Hi, I'm JAVIN. My registration number is 24BME1086. So today we are going to discuss a question on moment on a particular axis. So let's hear the given question. A uniform beam of length 4.5 meter and mass 25 kg is supported at its ends by two vertical rods. A 50 kg box is placed 1.2 meters from one end of the beam. Let's calculate the tension on the ropes. So this is the figure given, and the box is 50 kg, and let's consider this tension as T1 and this tension as T2. And as this is uniform beam, the force will be acting in the midway of the beam, which is 2.25 meters from each. So let's find the sum of the vertical forces. Here, phi equals 0. So T1 plus T2 equals 50 kg plus the beam is 25 kg into 9.81, which is G, equals 75 into 9.81 equals 735.75 Newton. So let's consider this as equation 1. And now we have to find the moment on point A. Moment formula is force into perpendicular distance. So here the sum of moment on moment A equals 0. This force is acting 50 kg into 9.81, and the perpendicular distance from A to this box is 1.2 meters. Yes. And this is clockwise, so we are going to take it as positive. And here the next force is acting here, it is midway, so plus 25 kg into 9.81 into the perpendicular distance is 2.25 kg. Again here it is clockwise, so we are going to take it as positive. And here T2 is acting anti-clockwise, so we are going to take it as minus, and T2 into perpendicular distance is 4.5 equals 0. So 50 kg into 9.81 into 1.2 meters plus 25 kg into 9.81 into 2.25 equals T2 into 4.5 meters. So 490.5 into 1.2 plus 245.25 into 2.25 equals T2 4.5. So solving we will get 1140.4125 by 4.5 equals T2. Now T2 equals 253.425 Newton. So let's consider this as 2. So substituting 2 in 1, T1 plus 253.425 equals 735.75 Newton. So T1 equals 735.75 minus 253.425. T1 equals 482.325 Newton. Now we have calculated T1 and T2. Let's solve this question and understand the concept more clearly. So calculate the tension if the box is moved to the center of the beam. So now the free body diagram will be the same 4.5 meters. The boxes move to the center, so this distance would be 2.25 meters. Let's name this points as A and B, this as T1 and T2. Box is 50 kgs and the beam is 25 kgs. The force of the beam would act in the midpoint as it is a uniform beam. Okay, now summing the vertical forces, F of y equals 0, so T1 plus T2 equals 50 kg plus 25 kg into 9.81, which should be equal to 735.75 Newton. Considering this as equation 1, now taking the moment on point A, as we know the moment formula is force into perpendicular distance. So solving it, we will get from boxes 50 kg into 9.81 into the perpendicular distance is 2.25 and this is and clockwise direction, so we are going to do this plus, and now the moment of the beam, weight of the beam is 25 into 9.81 into the distance is again 2.25 meters, and this is also clockwise, so plus, then taking T2 into 4.5 meters, 4.5 meters, then it is acting anti-clockwise, so we are going to give it as negative equals 0. So solving this, we will get 1103.625 plus 551.8125 equals T2 to 4.5. So 16,655.4375 by 4.5 equals T2. We will get T2 as 367.875 Newton. And now, as the box is in the center of the beam, so T1 plus T2, T1 and T2 should be equal. For confirmation, we will solve T1 plus T2 equals 735.75. This is equation 1. Now substituting 2 in 1. T1 plus 367.875 equals 735.75. T1 equals 735.75 is 367.875 should be equal to 367.875 thus T1 plus T2 equals 367.875 hence we have found the tension using moment of law. Thank you guys.